Welcome to this brief Excel tutorial in which we're going to show you how to create formulas in Excel and basically use Excel in order to do various mathematical applications of some raw data. So you're able to access this raw data on Blackboard, so please pause this video, open the data so that you can follow along. Okay, so at this time you should have this video running and have the raw data open in Excel in front of you so that you're ready to proceed. Okay, so first let's walk through this raw data. We have some time with some minutes, and notice the units are up at the top because we never mix the numerical data with the units. Excel cannot handle it and will not be able to use formulas if, for example, instead of putting the units at the top, you put 1 minute here. You can see now that even the formatting has changed. This is now left oriented because Excel sees this now as text instead of as a number. And so it will not perform any mathematical operations on this. It will not plot it correctly. It will not multiply, add, divide, whatever. Can't do it. So make sure your units are at the top in the header for your data and not actually embedded with the numerical data. It's a big source of error. Okay, so we have time, so we have 5 time points taken in minutes, so this is minute 1, 2, 3, 4, 5. Then we have 3 responses, and this can be anything. I just kept it very generic here, just response 1, response 2, response 3, and units. So this could be amount of CO2 evolved, this could be whatever you're measuring, rates, etc. So whatever you're measuring over time. And remember, the units stay in the titles and not with the data. Okay, so we've got 3 responses, and we're going to multiply this raw data by a constant. We're going to find the average, and we're going to find the standard deviation, because Excel is very powerful at all 3 of these things, and these are skills that you can apply to many different situations in science. Okay, so for example, we have this raw data that we can highlight and just copy it down here so that we're going to manipulate it. So you never want to manipulate the data itself after you've entered it into Excel, because there's always that risk that you're going to type something wrong and ruin it and have to go back to your notebook to retype it. So always just copy and paste, and we can do the math on a separate row, separate column. So the first thing we're going to do is multiply the raw data by a constant. So for example, maybe these are UV vis numbers. We're looking at absorbances, and we need to multiply the concentration by the extinction coefficient in order to calculate the absorbance. So that would be our response. So each one of these is going to be multiplied by the exact same number. So you could do it the long way, in which, well, let's just multiply by 2, because then the math is very easy. We'll say our extinction coefficient is 2. So in order to enter a formula in Excel, we have to tell Excel that it's going to need to do math. So you use the equal sign. That tells Excel, okay, now you're going to have to do a mathematical operation on whatever I tell you. So if you're doing this in a calculator, you're tempted to, type in 0.6 and then times, which is the little asterisk in Excel, times the extinction coefficient. Except when you type this and press enter, you get the correct answer in Excel, but you're going to have to type that for every single one of these cells. The faster way to do it is Excel is able to figure out what you're trying to tell it and is able to apply formulas to different cells. So if we're doing the same operation, we're taking a cell, multiplying it by a constant. What we can do is enter the formula once by telling Excel, by telling Excel the cell location. So we want to take B1, our first time point 1 in response 1, multiply it by this coefficient. We press enter, we get the correct answer. So what we can do now is, if we take this formula and we need to do the same formula in the cell immediately below this, we would then need cell B6, and then B7, then B8, then B9. What Excel can do is it can automatically adjust this formula to B6, B7, B8, B9 based on where you copy the formula using this small black square in the lower right hand corner. So it's right here. You see your cursor, which is normally white and kind of puffy, white and puffy plus. As you hover it over the small black box in the lower right hand corner, you see it becomes a different color. It is now black and skinny. So this is exactly what you want to see. And then left click and drag down. So you can see at the bottom of the screen here it says drag outside selection to extend series or fill, drag inside to clear. So what that means is if we drag downward, what Excel is going to do is going to apply that formula to the different cells in this column because of what we told it in this cell. So Excel is going to be able to do all of that math for us because we were able to move that formula. So, and then it just adjusts the formula to say, so we started with B5, then it goes down one here, so it moves down one cell here. So B6, B7, B8, and B9. So the next thing we want to do is we have to do that for all of this data, all of these data rather. We can apply that to each individual column in the same way that we applied it to the row by using that small black box, left click, drag to the right. So now instead of in the B column we need the C and the D, and we can see that Excel immediately filled in that formula. So then C5 and then D5. So based on the position it changes the column letter or the row number. And then we can do the same thing with all of these rows. Click and drag, and suddenly, and we can go back and check, you know, like this is twice of that, all the way down. So Excel did all of this math correctly, and that took a fraction of the time as trying to multiply it, especially when your coefficient is a much larger number than 2 or a complicated number. You don't want to put that pressure on you in order to make sure all of your math is correct. Excel does all of the math for you. As long as you click the lower right hand corner and you can drag. And you can actually do both simultaneously. Oh, at least you used to. So you can do down and then maybe across all at once. And you can copy that formula very, very quickly using this simple trick. Okay, so something else that science requires a lot of is finding the average. And you could take the time to add this up and divide by 3, but Excel has a built-in formula because this is such a useful tool and such a common mathematical operation. We can just type the the equal sign, and then we start typing average, and we can see different formula options for Excel pop up. So the first one here, average, returns the average, the arithmetic mean, of its arguments, which can be numbers, names, arrays, or references that contain numbers. So what this says is that this will do the average for us. So you type in the word average and you can click, and there's different averages here that you can choose, and you can read the different descriptions. But for most of the time, average, just plain average, will do. You type a left-hand parentheses, and now you see it's giving you instructions for the different numbers. And we can either type in the numbers individually, but I don't like to do that. I prefer to tell Excel where the locations are, and I'll show you why in a second. So we want to use cells B14, so you can just click, left click, normal click with your mouse, and then you can drag across to do the average of these 3 time points. Then you finish off the formula with a right-handed parentheses, press enter. And glancing at these numbers, the average, yes, is about 1.3333 repeating. And then, following the information I just showed you, we want to do the same average for all of this data, all of these data. So we can click on that small box when our cursor looks like a small cross, and drag down. And then you can adjust the decimal places and do fancy formatting things. Oops. Fancy formatting things to make the data look nicer, or to follow the correct number of significant figures or what have you. Okay, so why did I have you not type in these individual numbers? Why did I have you click and drag on the cells? It seems like it's a little silly. Whatever. What if later on we realized that we weren't supposed to multiply by 2, we were supposed to multiply by 2.1, for example? Well, now we'd have to go back and redo all of that math. If we did the average of 1.2, 1.4, 1.4, which was the original, now this is wrong, because now we would have to go back in and fix all of these numbers individually. However, if you just tell Excel to calculate the average of whatever numbers are in this location, it automatically adjusts. So when you find out that your math is wrong or what have you, that took me less than a minute to correct, whereas if you had typed in the individual numbers, it would take you much, much longer. Okay, so we've multiplied the raw data by a constant. This can also be applied to addition, subtraction, division, or any combination of formulas that you'd like to apply, including averages. The final thing is finding the standard deviation. So standard deviation, important tool, especially in biology. That's our good statistical analysis that you should definitely look at, depending on the situation. So this is a standard formula typed in by Excel as well, but the abbreviation is a little different. So to do standard deviation, which is a very complicated formula, it's STDEV. And you can see that there's several different options here. So this one is for an entire population, STDEV.P. STDV.S is based on a sample, ignores logical values in text. A, this includes logical values in text. And PA, so it gets very, very fancy here. So a lot of time you're going to do STDEV.S, but definitely follow what your instructor tells you to do. So same as we did for the average, you're going to do one parentheses, left parentheses, highlight your cells, we don't type in the individual numbers, end parentheses, press enter, and that is your standard deviation. We can copy this down, and then we're all done. And you can do fancy formatting to make sure that you have the correct number of significant digits. Okay, so now you should be able to use Excel to do these very powerful mathematical tools during your science class in lab.